All right, welcome to statistics. We've already watched this video, so we're going to begin the first night's notes. Now remember, anytime the notes are going too fast for you, you can always hit pause. You can hit rewind. If I'm talking too fast, if you're on YouTube, all you have to do is go to the speed setting and make me go 0.75. Or you could go 0.5. But that would probably take too long. So, whatever works for you, but you're in control. Now, instead of my sloppy handwriting, so this is already pre-filled, so I'm just going to drag down and you're going to fill in. Again, if I'm going too fast, please just hit pause, catch up, and come back in. So, what is statistics? Okay? That shouldn't happen. Statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. So, copy down those four words. This is everything stats is about. We go out and collect data. We organize it so that we can analyze it and then interpret what did it mean. And then based on all that information, decisions are made. Statistics is actually one of the most applicable math courses you'll ever use because it applies in science and business. And pretty much across the board, most jobs use statistics. Sports, plenty of fields use statistics. So it is very good to have a general idea of how it works. Not to mention, a lot of stuff in our daily lives talks about statistics. The news, reporting on politics, it's all over the place. And once you start learning these terms, you will start seeing it everywhere. I don't know why this board is doing that, but we'll move on. Now, what is data? Data consists of information. Stuff. Just info. Coming from observations, things we watch, see, things we count, measure, or responses, like of a survey. So, example, people who eat three daily servings of whole grains have been shown to reduce their risk of stroke by 37%. 70% of the 1,500 U.S. spinal cord injuries due to spinal cord injuries to minors results from vehicle accidents. And 68% were not wearing a seatbelt. Scary one there. All right. Data sets. Population is a collection of all the outcomes, responses, measurements, or counts that are of interest. Okay? Keyword is all there. All right, so you might want to circle that, underline it, because that is the population. It's the entire thing. So if you think about the population of the United States, or the population of Missouri, or the population of Rockwood Summit, it's everybody there. Now, what's a sample? Well, a sample is a subset, a section, a piece of the population that we actually examine in order to gather information. You cannot, let's say you want to make a decision here at school. You're not going to go and ask every student in school. The principals aren't going to ask every single student. Yes, they could. They could survey the entire school. That's a lot of data to compile and interpret and analyze. So we usually go with a sample of the school. Okay? And that's the subset of the population we actually examine in order to get the information. Now, identifying data sets. We're going to identify the population and the sample of each. Okay, so in a recent survey, 1,708 adults in the United States were asked if they think global warming is a problem that requires immediate government action. 939 of adults said yes. So think about that for a second. What is the population and what is the sample? Okay, so what are we looking at? What's a common word we see throughout this? Adults, okay? So, we know we're talking about adults. In a survey, 1,708 were asked. This is the number that were asked, the 1,708. Now remember, we said a sample is a subset that we actually examine. So how many did we examine? Did we examine 1,708 or 939? That is called a distractor. We didn't examine 939. 939 were just the yeses. If we subtract 939 from 1,708, we'll get another number. Those were the no's. But those were not how many people were asked. The sample is who was asked. So the 1,708 adults is the population. Sometimes it's easier to go backwards. Now, what's the population? Adults in the U.S. Okay? Moving on. Maybe. All right. For quality control, Mars employees, not the planet, the company, Mars employees took 1,600 M&Ms and tested them for weight, color, and taste. So again, let's think backwards. Maybe it'll be easier if we go that way. So we're talking about 1,600 M&Ms. That's how many we took. That's how many were evaluated. That's the sample. 1,600 M&Ms. What's the population? All the M&Ms. Okay? And only 1,600 were tested for weight, color, and taste. So what was actually taken and evaluated is a sample. The population is the entire amount. I don't know what's happening, sorry. Okay, C. Last school year during advisory, counselors randomly selected 50 high school students. So again, let's work backwards. Who was selected? 50 high school students. That is a sample, 50 high school students. Okay, so what's the population? All students. All right, more vocabulary. What is a census? You may have heard this before about the U.S. Census taken every 10 years. Well, here you go. A census is an attempt to get information about every individual in the population. So before we talk about how you can't ask everybody, so you take a sample, well, the census is that attempt every 10 years to try to get information from everybody. It's time-consuming and expensive. That's why it takes only every 10 years that we do it. Right, parameters and statistics. A parameter is a number, okay? So it's a statistic. But a parameter is a number that describes a population characteristic. Keyword here. That should not happen. Population. Okay? Parameter, population. Notice they both start with a P. So parameter describes a population, like the average age of all people in the U.S. A statistic is a number that describes a sample statistic. So again, luckily, they both start with S. So a statistic looks at the sample, a parameter looks at the population. A statistic is the average age of people from a sample of 3 states. Okay? All the people in the U.S., parameter, that's the entire population. Sample from 3 states, the sample is a statistic. So, there you go. P and S. A parameter comes from a population, a statistic comes from a sample. So, P, S. Alright, let's suppose you want to know what percentage of RSHS seniors participate in CCE. You send out a survey to all seniors, but only 100 respond. Out of the 100, 12 participate in CCE. Okay, so we're trying to find out about all the seniors. That's our population. So all Rockwood Summit high school seniors. Identify the sample. Well, the ones we could evaluate are the 100 that responded. What data did you receive from the survey? Well, we found out that 12%, that's not right. That was weird. 12% participate in CCE. Okay. Now, last question. Is that data a statistic or a parameter? Well, is it based on every senior responding, the population, or the 100 that answered? Since it's the 100 that answered, it's a sample, so it's a statistic. S and S. All right, branches of statistics. Well, there's descriptive statistics, which involves organizing, summarizing, and displaying data, such as tables, charts, and averages. Okay, so if you can look at a table or a chart, okay, it gives you that information. That's descriptive. Inferential. Sorry about that. Inferential statistics involves using sample data to draw conclusions about a population. So if we go back to the CCE example, what part of that was descriptive and what could be inferential based on the survey? Well, let's go back. Descriptive are tables, charts, and averages. Okay? So looking back at this example, okay, we don't have any tables or charts to look at. But averages. We know that 12% okay, 12% take CCE. Now, inferential. What inferences can we make? You know, in your own words. Not a lot of seniors take CCE. That's the conclusion we can come to. Okay, qualitative data consists of attributes, labels, or non-numerical entries. Qualitative, qualities. If you describe of your friend, someone else, what qualities do they have? Well, they're faithful, they're loyal, they're supportive. Those are not things you can put a number to. All right? Non-numerical. So, your major in college, where you were born, your eye color, these are qualitative as opposed to quantitative, quantity, numbers. Okay, so categorical variables are variables with numerical values for which arithmetic, math, operations such as adding and averaging do not make sense, are actually considered categorical variables. So, even though these are numbers, okay, You would not average area code, zip code, your student ID, or your social security number. So even though these are numbers, they're not eye color, favorite color, your car type, these numbers it would not make sense to do math on. So they're still considered categorical. So that I alluded to before, quantitative, quantity, numbers. So numerical measurements or counts, such as age, weight of a letter, temperature, or so forth. So, qualitative or quantitative. Okay? Hair color, that's qualitative. I'm just going to abbreviate, qual. Hair length, well, that's a number, and it's something we could do something with. Okay? So, quantitative. Your jersey number. Your jersey number is kind of like your student ID or your social security number. So even though it's a number, that's going to fall under qualitative. Inches of rain per year. Okay? So that's something we can measure and analyze and average and so forth. So that's going to be quantitative. And then there's your age. Okay? Well, I can take a bunch of people's ages and average them, list the range, do all kinds of analysis to that. So that's also going to be quantitative data. Okay, so remember, your jersey number, I'm not going to take everybody's jersey number and average it. That wouldn't tell me anything. But the average age of a group of people, that's something.